Everybody, it's Professor Mitchell. We're continuing with Chapter 11, and today we're talking about Section 11.4, which is nonlinear inequalities in one variable. So I have already decided that this is going to be a two-part video. In this first part, we will talk about solving polynomial inequalities of degree 2 or greater. And then in part 2, we'll talk about solving inequalities that contain rational expressions with variables in the denominator. Solving these two kinds of problems is very similar. It's just that the problems themselves are kind of long. And so I think this will be best as a two-parter. This is still SLOD. We are solving linear and nonlinear equations and inequalities. All right, so I like to start with a quote easy example of a nonlinear inequality. So suppose that you were seeing an inequality like this for the first time. X plus 4 times x minus 1 is greater than 0. So I want to show you something that you might try the first time that you ran into this. And then we'll talk about why what we're going to try doesn't work. And so that's why I have this note at the top that says, don't write this down. I'm not going to spend a lot of time on this. So here we have x plus 4 times x minus 1 is greater than 0. So suppose we decided to just say, okay, I am going to divide both sides of that inequality by, let's say, x plus 4. Whoops. Okay, so on the left-hand side, of course, the x plus 4s cancel, leaving me x minus 1. And on the right side, 0 divided by x plus 4 is 0. That leaves me x minus 1 is greater than 0, which would, of course, mean that x is greater than 1. Wow, that was really easy. Well, unfortunately, it was a little too easy. So let's see if we can figure out what's wrong with this. I don't see anything wrong with the left-hand side. X plus 4 times x minus 1 divided by x plus 4 would be x minus 1. And I don't see anything wrong with the right-hand side. 0 divided by x plus 4 is 0. So if there's nothing wrong with the left-hand side and there's nothing wrong with the right-hand side, well, where could the problem be? Well, what about right in the middle? It would be easy to overlook this. All right, but do you remember that there's a rule for inequalities that says, for example, let's say you have two totally different problem, 2x is greater than 12. There's a rule that says you're allowed to divide both sides by 2, and that would give you x is greater than 6. On the other hand, if it was negative 3x is greater than 15, and you divide by negative 3, you remember the special thing that happens? Because we divided both sides by a negative, this would become x is less than negative 5. All right, so then I look up at my original problem and it started off as a greater than, and it's still a greater than, which means that I'm assuming x plus 4 is positive. But of course, I don't know that x plus 4 is positive, right? X plus 4 is sometimes positive, sometimes negative. So forget about this. It's not going to work. So let me show you the right way to do it. Unfortunately, it is a bit more complicated than this, but it does make sense, and I'm going to try to help you make sense of it. Okay, so the idea is, and in this class we don't talk a lot about polynomial graphs. For that, you could take my pre-calculus class. Polynomial functions have graphs that are smooth and continuous. So smooth means they don't have any sharp corners. Continuous means you can draw them without picking up your pencil. And that's the important part for what we're talking about now. Because they're continuous, they can't skip points. The only way they can switch from positive to negative or negative to positive is by crossing the x-axis. So the first step in figuring out where a polynomial is positive or negative is to figure out where it crosses the x-axis. Okay. All right, so here are the steps for solving a polynomial inequality. We're going to do 3 examples. Step 1 is to write the inequality in standard form and then solve the related equation. So the related equation is just the equation that you get by replacing the inequality symbol with an equal sign. Step 2 is to separate the number line into regions using the solutions from step 1. And of course, this will make a whole lot more sense when we actually do it. All right, and then in step 3, for each region, choose a test point and determine whether its value satisfies the original inequality. All right, and then the solution set will include all the regions whose test point is a solution. And then we come to the point where deciding whether or not to include the solutions from step 1. If the inequality symbol is greater than or equal or less than or equal, the values from step 1 are included. And if it's less than or greater than, they are not included. Okay, so that's a lot to take in. But again, I'm going to walk you through all these steps in these 3 examples, starting with the one that we just tried and failed to do. So let me get on the right page of the tablet here, and then we will switch over. Okay, so here's this inequality again. X plus 4 times x minus 1 is greater than 0. So step 1 is to solve the related equation, which would be x plus 4 times x minus 1 equals 0. And I hope at this point it's okay if I just say the solutions of that equation are x equals negative 4 and x equals 1. I think at this point you can handle that. All right, step 2 is to draw my number line. So I'm going to plot these 2 numbers, negative 4 and 1, on the number line, which creates 3 regions. And I'm going to call those 3 regions A, B, and C. Okay. Now, before I go over to the next slide, what part of step 3, I think they called this part of step 3, was to choose a test point from within each region. Okay. So that just means first we're going to pick a number, any number that is less than negative 4. How about negative 5? Right here, right about there. And then pick a number, any number between negative 4 and 1. Can you guess what number I'm going to pick? I'm going to pick 0. I always pick 0 whenever I can. And then pick a number, any number that is greater than 1. I'll pick 2. Okay, so my test points are negative 5, 0, and 2. So now, going on to step 3, I am going to make a table. And the table is going to have my region, A, B, or C, my test point, or let's call it a test value. Then next to that, we'll put the inequality. What does the inequality look like when you plug in your test value? The original inequality is x plus 4 times x minus 1 is greater than 0. And finally, I'm going to say whether that inequality is true or false. Okay. So we have 3 regions, A, B, and C. My test values are negative 5, 0, and 2. Okay, so now let's make a copy of my inequality. I'm just going to leave out the x because then I'm going to replace that x with a -5. And you know what? While I'm here, why don't I just do that for all of these? Okay, so here we go. When I put -5 into this inequality, it becomes -1 times -6 is greater than 0, which is going to end up saying 6 is greater than 0. So is that true or is that false? That is true, right? All right, so that means that my solution set is going to include all of region A, all right? Because remember, the only place where this inequality can change from true to false or false to true is at those solution points -4 and 1, all right? So if it's true at -5, then that means it's true at all numbers that are less than -4, okay? So in fact, why don't I do this? Going back to the last slide, I'm just going to go ahead and color in this whole entire region A. Okay, so that entire interval is part of the solution set. Okay, now we will go to region B. I'm going to put in 0 for x, and that is going to give me 4 times -1 is greater than 0, which is going to say -4 is greater than 0. Is that true or false? That is false. So region B is not part of my solution set, none of region B, all right? And then going on to region C, if I put 2 in here, that gives me 6 times 1 is greater than 0. 6 times 1 is 6. 6 is greater than 0 is still true. So that means all of region C is part of my solution set. So let's go ahead and color that in. All right. So now the only thing left to do is talk about the, they're called the boundary points, the solutions from step 1. In other words, should -4 and 1 be included, or that should they not be included? Well, in this case, they should not be included. You know what? I think I'll just put step 4 up here. -4 and 1 are not included because the inequality, I hope you can put up with all of my abbreviations, is a greater than as opposed to a greater than or equal. If you were to put either one of these numbers, -4 or 1, into the original inequality, what would come out would be 0 is greater than 0. 0 is greater than 0 is false, okay? But if the inequality symbol was a greater than or equal, it would be true. So in that case, I would include them. But since it is a greater than, I am not going to include them. This is also part of step 4, I guess, is I'll just put these open circles here. All right, and now we're going to write the solution set. So these solution sets are always written using interval notation. And the way that you write interval notation for this, for the first part, would be -∞, -4. And then for the second part, it would be 1, infinity. And that is the solution set for the inequality x plus 4 times x minus 1 is greater than 0. All right, so now let's go on to letter B. We have 2x squared minus 5x is less than 7. Okay. Now, I'm doing something that I guess is a little different from what was written in the list of steps. The list of steps talked about putting the inequality in standard form first. I don't really think that's necessary because when you write your related equation, which in this case would be 2x squared minus 5x equals 7. I mean, you're probably going to have to write that equation in standard form anyway. So that would be 2x squared minus 5x minus 7 equals 0. I am going to solve that by factoring. So this must be 2x and x. This must be 7. This must be 1. This must be minus. That must be plus. Right? Okay, and again, hopefully this makes sense. If 2x minus 7 times x plus 1 is 0, that could only mean that x is either 7 halves or negative 1. Okay, so those are what's called my boundary points. Those are the points that are going to get plotted on the number line. So let's draw that number line. Okay, so of course negative 1 would go first because it's less than 7 halves. All you really have to understand about 7 halves for that part is that it's positive. And 7 halves does happen to be 3.5, right? So it'll go over here somewhere. I'll need to know that when I start picking my test points. Okay, so once again, we have 3 regions, A, B, and C. All right, so let's pick our test points. First, give me a number, any number that is less than negative 1. How about negative 2? Next, give me a number, any number that's between negative 1 and 7 halves. How about 0? And finally, give me a number, any number that is greater than 7 halves. Remember, 7 halves is 3.5. So how about 4? So far, so good? All right, so now we will make our table. Uh-oh. Not really sure why phone calls come through to my tablet. I thought I had it set up so that they don't. Okay, so how did we do this? Region, test value. And then here we put the original inequality, which was 2x squared minus 5x is less than 7. And then we ask ourselves, is that true or false? All right. The test values we picked were negative 2, 0, and 4, right? Yes. All right, here we go. So I'm going to make 3 copies of 2 blank squared minus 5 blank is less than 7. 2 blank squared minus 5 blank is less than 7. 2 blank squared minus 5 blank less than 7. All right, so now let's test that out, starting with negative 2. The square of negative 2 is 4. 4 times 2 is 8. Plus 10. Is that less than 7? Is 18 less than 7? No, it is not. So region A is not part of the solution set. If I put in 0, that just gives me 0 is less than 7, doesn't it? And that is definitely true. I like to write true in green. It's sort of like, green means go, red means stop. All right. And then finally, plugging in 4. 4 squared is 16. 2 times 16 is 32. 5 times 4 is 20. 32 minus 20 is 12. Is 12 less than 7? No, it is not. So out of regions A, B, and C, the only region that satisfies this inequality is region B. So going back to the number line, we're going to color in just this interval. Okay, so now we have to think about the boundary points. Once again, they are not included. Remember, the boundary points are 7/2 and -1. They are not included because of the less than, as opposed to a less than or equal. So again, I'm going to put round circles at those endpoints. And then when I go to write my interval, the interval is going to be parenthesis -1, 7/2 parenthesis. I should have made a bigger deal about this maybe in the first example. Recall that when you write interval notation, you use parentheses if the number is not included. Okay. In the next example, you're going to see what to do if those numbers are included. Okay. But in the meantime, the solution set for this inequality is all real numbers between -1 and 7/2. All right, and that brings us to our last example for part 1, which is this thing. Okay, and as usual, at any time, if you want to pause and try it yourself and then come back and compare notes, I always encourage that. All right, step 1, we solve the related equation, x minus 6 times x minus 4 times x minus 2 equals 0. The only way that x minus 6 times x minus 4 times x minus 2 can equal 0 is if x is 6, 4, or 2. So in this problem, there are 3 boundary points, which means when I go to do my number line, and of course those numbers are going to go in the order 2, 4, 6, that is going to create 4 regions. So we're going to have an A, B, C, and now we're going to have a D. Okay. So now let's pick our test values. Feel like I can go a little faster with this part now. So how about 1, 3, 5, and 7? Right? Okay, so now I'm going to go make my table. My table is going to have one more row than it did before. So we have the region, we have the test value, we have the inequality, x minus 6, x minus 4, x minus 2. And I think it said less than or equal, right? Yes. And then we'll ask ourselves, is that true or false? Okay, so we have A, B, C, D. And the test values are 1, 3, 5, 7. Oh, I could have used 0. Oh well. 1, 3, 5, 7. I got stuck in that pattern there. All right. So now let's go ahead and make 4 copies of this inequality. La, da, 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 dee. I wish I could figure out a way to copy and paste when I'm writing stuff by hand. Okay, last one. And remember, there's going to be a number there. We're just taking out the x. All right, so first, put a 1 in there. And that's going to give me -5 times -3 times -1, which is 15 times -1 is -15. Is -15 less than or equal to 0? Why, yes, it is. So region A is going to be part of the solution set. Then we go to 3. Okay, that gives us -3 times -1 times 1, which comes out to 3. Is 3 less than or equal to 0? No, it is not. All right, then we go to 5. Which gives us -1 times 1 times 3, which is -3. Is -3 less than or equal to 0? Why, yes, it is. And then finally, 7, 7, 7, which gives you 1 times 3 times 5, which is 15. Is 15 less than or equal to 0? No, it is not. So the two regions that are going to be included in the solution set are region A and region C. So let's go back here, color those in. So there's region A, there's region C. Okay, so now the very last thing we have to think about is, are the boundary points included? This time they are included. We are going to include 6, 4, and 2 because the inequality sign contains equals, right? It's a less than or equal as opposed to just a less than, okay? So let's put some big, bold, colored in dots on those 3 numbers. Okay, so this is another one where we're going to have to use the union symbol. First, we have region A along with that endpoint. That's going to be written as -infinity, 2. And then what do you do when the number is included? You put a square bracket. The square bracket means that that number is included. And then I'm going to put a union sign, and then I want the interval from 4 to 6 with the 2 endpoints included. So I'm going to use 2 square brackets on the 4 and the 6. Okay, I know they're long problems. They have quite a few steps. I don't think they're all that hard. You just have to practice. And then each time you do it, it'll probably go a little faster. All right, so we're going to leave it there for part 1. Next time, we will look at solving rational inequalities. All right, so we'll see you then. That might be about a minute from now if you just press play. All right, so we'll see you for part 2.